Hello, my name is Arturo Ángeles. I am a senior at San Jose State University. I hope to graduate in the spring of 2026, and this is my presentation on my topic that I chose. It's supernova and novae. The overview, what I will be going over, will be what is a nova, what is a supernova, what's the difference, the types of supernovae, the life cycle, the importance of a supernova, the modern observations that we have today, a conclusion, and my works cited. What is a nova? As I was doing my research, and it was really interesting research, I learned that a nova was a powerful explosion. It occurs in a binary star system where two stars orbit very close. One star is obviously a white dwarf, and the other is its companion star. It's star of hydrogen. As the white dwarf pulls hydrogen from the star pressure, um, as the white dwarf pulls hydrogen from the star, the pressure and the temperature increases, and eventually a burst of nuclear fusion causes a nova. And right here, an image to the left is a real image captured, and it's showing remnants of a nova. Now, what is a supernova? A supernova is a massive explosion when a star dies. That's just to keep it simple. But typically, it occurs when a star is running out of a nuclear fuel. So, like, essentially, when I was doing my research, I was doing my research, and like it says right here in my slide that typically when the star is running out of nuclear fuel and it's it causes its core to collapse. So it releases a burst of light and energy, and it obviously I think something that I found very very interesting was how when this star dies and it explodes, it creates elements for our planet, and that was very interesting. That was very that was something new that I learned. And not only that, but I looking at this image to the left. It's really really beautiful to say the least. I doing my research. I look at these photos and I'm like, I wonder what's real or not. But um, these are real images that are being captured through the telescopes, and yeah, very very beautiful images. Now going forward, wow, what's the difference? As I was doing my research, I was kind of confused at first. Not really, but as I was having to read more and more on the difference between the two, it was rather simple after reading a few times. But pretty much a nova is obviously when a white dwarf um, and its companion star pretty much collide, and it's something that can happen multiple times, and typically the white dwarf doesn't get destroyed. Um, Rather, when a supernova occurs, it cannot be repeated multiple times, and that was the main difference that I took from my research. And the reason being is because it's because when a supernova occurs, it's the end of a star's life, um, and as I go forward, I will be talking about two types of supernovas, while they also have their subtypes that I will also be addressing. As I address the different types of supernova, they are categorized in two types while having their subparts. Type 1 is a supernova that lacks hydrogen in their spectrum, and it has a type 1a supernova, and that is pretty much it occurs in a binary system where a white dwarf accumulates matter from its companion star, and it reaches critical mass and it explodes, right? And there's another supernova type, which is 1b, and I'm doing my research. It was showing that it's pretty much it forms when a massive star loses outer hydrogen layer, often due to stronger stellar winds or binary interaction, and then it collapses. And then type 1c, which is a supernova similar to type 1b, but it lacks helium in its spectrum, meaning it has lost both hydrogen and helium layers. Type 2 supernova shows hydrogen, which is different to the type 1. And doing my research on the type 2 subparts, type 2p is a supernova. It shows like a plateau in its brightness, showing it's staying it's like pretty much it stays at a peak luminosity for like a few weeks due to its combination of hydrogen and type L, which is a supernova that have a linear decline in its brightness, indicating that less hydrogen in outer layers compared to type 2p. Moving forward, as I talk about the life cycle, just kind of wrapping it up. Pretty much both the novas and supernovas, they begin with a star. They form a cloud of gas and dust, and the star goes through its main life stages, right? A nova a nova happens in a binary star system, obviously where a white dwarf pulls gas, mostly hydrogen, from a nearby companion star. That's pretty. The nova then explodes. It occurs in the surface of the white dwarf as a result of the gas accumulation, which was created from the pressure and the heat, right? And in the aftermath, there might leave a black hole, a neutron star, or sometimes nothing at all. And their elements, they spread into space, and it helps create new planets and new stars. And the importance of these supernovas I was doing my research, and I found 4 key reasons. One of them being the creation of the elements that these supernova explosions create for the universe and for our planet. Also, the formation of new stars that they create. The shock of the explosions create birth of new stars in the solar systems. And I was doing my research, and I got these two facts from these articles as well, that the supernovas they help understand the expansion of the universe, and they also help create black holes, which is something that's, I mean, I wouldn't say important, but I thought it was important, like, because it's something that's just natural, and I don't know that. I mean, I don't know if, how often that those happen, but they are. I know they're real. So that's those are pretty interesting reasons why supernovas are important. And during my research, I found two important, in my opinion, two important ways that in modern day we observe these supernovas. And one of them being obviously these advanced telescopes, NASA's Hubble Space Telescope and the James Space Telescope. During the research, I've seen a lot of high, like it says, a lot of high resolution images, um, and I felt that there was a lot that when you look at these photos, they don't seem like real because they're just so mesmerizing. But doing research and I was looking at these articles on NASA and very very stunning photos. And another big one another reason, another thing that stood out to me was the type of supernova, type 1A. They use these as standard, like a standard candle. The brightness make them reliable, measuring them from a far cosmic distance and the universe's expansion rate. In conclusion, I learned many new facts about the supernovae and the novas. I learned the differences, how they were created, the different type of supernovas, the importance it has on our planet, the life cycle, and the modern day tools used to observe these natural occurrences. And as I continue to move forward, I will take the importance of these beautiful explosions and how they create elements for our Earth and for our universe. These are my works cited. I also included a few. I included my works cited on my images, and I really enjoyed doing the research on this topic. It was actually really really cool. I really enjoyed it. I learned a lot. I learned a few new things. And it was definitely I got lucky with the topic, and I hope the presentation was decent, and I hope the slides were nice and visible. And thank you so much.